Okay, we're looking at the next lesson, tests for parallelograms, conditions for parallelograms. Now, we talked yesterday about what parallelograms are. Now, today we're going to look at if we have a quadrilateral, how to prove whether it is a parallelogram or not. One way to do that is if both pairs of opposite sides are parallel, then it's a parallelogram. Now, the way we could do that is, how do we prove lines parallel? Well, we use the slope formula to do that. Another way would be if both pairs of opposite sides are congruent. How do we do that? We use the distance formula. The next way, if both pairs of angles are congruent. Now, we don't have a formula for that. We're not going to measure the angle, so if they tell us that the opposite angles are congruent, I forgot to put that in there, didn't I? Both pairs of opposite angles are congruent, then it is a parallelogram. The next one, if the diagonals bisect each other. And you'll recall from the last lesson, we're going to use the midpoint formula for that. And the final way to prove whether they are or not is if one pair of sides is keyword both, the one pair is both parallel and congruent. And the way we would do that is, to prove them parallel, we'd use the slope formula. And if we proved them congruent, we would use the distance formula. Okay, you don't have to use all 5 of these to prove them parallel. You just have to prove one of these cases true to prove that you do indeed have a parallelogram. So let's look at this first one. What would x have to be and y have to be in order to make this a parallelogram? Well, first, opposite sides would have to be congruent. So what we're going to do is we're going to take 4y minus 1 and set it equal to 3 times x plus 2. We're going to distribute, and that should be 4x minus 1, sorry. 4x minus 1 equals 3x plus 2, or plus 6. Subtract 3x, I get x, add 1, x equals 7. And then we're going to do the same thing for y. 3 times y plus 1, set that equal to 4y minus 2. Distribute, 3y plus 3 equals 4y minus 2. Subtract 3y, so y equals, add 2 to both sides, y equals 5. So, if x was 7 and y is 5, then that is a parallelogram because opposite sides, both pairs of opposite sides would be congruent. The next example, if m is a quadrilateral, find m so the quadrilateral is a parallelogram, where they would have to be congruent, so we're going to do the same thing. 4m plus 2 would have to be equal to 3m plus 8. Subtract 3m, subtract 2, and we would solve and get m equals 6. Now, the reason we would say it's a parallelogram is because of those red arrows that are there. Basically, they're saying that one pair of sides is both congruent and parallel. That would be the last reason that we wrote down in our notes. Okay, here we have an example where we have to graph something. So we're going to graph these points, 4, 4, 3, 1, negative 2, negative 1, negative 1, 2. So, looks like a parallelogram, could be, but we have to prove it. And the way they want us to prove it is to prove that both pairs of opposite sides are parallel. So we're going to use the slope formula. You'll recall we're going to find the slope of each side. So we're going to take EF and we're going to find the slope. We're going to say 4, remember subtract the y's on top, 4 minus 1 over 4 minus 3, which ends up being 3 over 1, which is 3. Now we're going to find the slope of FG, the next segment. FG is 1 minus negative 1 over 3 minus negative 2, which 1 minus negative 1 is 2 over 5. Okay, next slope we're going to look at is HG. HG is going to be 2 minus negative 1 over negative 1 minus negative 2. When we do that, we get 3 over positive 1, which is 3. Notice the slopes of HG and EF were the same. That means that segment is parallel to that segment. So far we have one pair of parallel sides. Let's find out what we get when we find EH, the last segment. EH, we're going to say 4 minus 2 over 4 minus negative 1, which gives us 2 over 5. Notice the slopes are the same. That means both pairs of opposite sides are parallel. That means that this is a congruent or a parallelogram. So compare the slopes. Well, we found that EF was parallel to HG. And we also found that EH was parallel to FG. Alright, next we're going to look at one that has a distance formula problem. This one can get a little confusing because we're talking about letters as points instead of numbers as coordinates. So we're going to prove that one pair of opposite sides is both parallel and congruent. So we're going to use the slope formula, but we're also going to use the distance formula. So let's pick a side. Let's go with AB and CD. We don't have to worry about the other segments, just those two. So we're going to find the slope of those first. So the slope of AB is going to be AB, we're going to say 0 minus 0 on top, and then 0 minus A. Leaves us with 0 over negative A, which is just 0. The slope of CD is going to be C minus C on top over B plus A minus B, my other x-coordinate. When I do that, I get 0 over A, which is just 0. So notice the slopes are the same. That means they are parallel. So we can say that AB is parallel to CD. Now we have to prove them congruent. So distance formula for AB. Remember, we take the x's, subtract them. So 0 minus A squared. Plus, we take the y's and subtract them. 0 minus 0 squared. We're using these two coordinates right now for this, for AB. We end up with negative A squared plus 0 squared, which ends up just being A squared. And the distance of the square root of A squared is A. Now let's do the same thing for CD. We're going to say B minus, or B plus A minus B, the other x-coordinate, squared. So what I did is I took this x, I subtracted this x. B plus A minus B squared. Plus the y-coordinates, which are both C, so it's just C minus C squared. This ends up being 0 squared, so that is eliminated. If I combine like terms, B and negative B, we end up again with A squared, which is A. The distance of both segments is the same, therefore AB is also congruent to CD. Because I have one pair of sides that's both parallel and congruent, This is indeed a parallelogram. Okay, 1 through 5, all you're doing is copying what we wrote as the notes in the beginning of the notes section. You're determining whether or not 1 through 8 is a parallelogram or not based on the markings that they've given you. Compare that to 1 through 5. You have to have one of those 1 through 5 reasons to say it is. I'll give you a hint. 3 of those are a no, 5 of them are a yes. Number 9, you're going to use the slope formula. So graph this, find the slope of each 4 segments, see if opposite sides are parallel. Number 10, you're using distance and slope formula. So here you're just going to see if you can prove that one pair of sides is both parallel and congruent. Number 11, you're using the midpoint formula. So there you're going to see if the diagonals bisect each other. So you're going to do the midpoint of both diagonals. If the midpoint's the same, then it does bisect it. 12 through 15, you should be able to do, and they're just like the first couple problems that we did. Let me scroll down so you can see those. Yeah, just very similar to the first examples. Go back to that if you need to. And then 16, you do not have to do number 16. We'll eliminate that one from the homework assignment. So that's it.